In the last video of this course, we looked at how we can define and implement methods within Go. Now in this video, we're going to be taking that knowledge a step further and looking at how we could define interfaces. So first of all, what is an interface? Well, I like to think of interfaces as a type of contract. Now, what do I mean by that? Well, let's dive into the code and see. Okay, so let's start off by defining the contract or the interface we want our object to implement. So let's do type employee, which will be an interface. And then within here, we want to define all of the methods that a struct must implement in order for it to satisfy this interface. So I'm going to say get name, and it'll be returning a string. Next, let's define a struct. So let's say we have an engineer, a struct which has a name, which is of type string. We then need to satisfy this interface. So let's define or implement the getName method that hangs off of this engineer struct. So let's do func e, and let's default to a pointer receiver to an engineer, and then let's do getName and returns a string. Now this is going to return e.name, like so. Cool. And let's change this a little bit. So let's do employee name plus e.name, just so that it's doing a little bit more than just returning the name field. And just to make sure this isn't just a standard getter, let's do engineer name. Cool. So now we have effectively implemented the engineer struct, which satisfies this employee interface. Now, what does that mean? Well, say I have a function that, say, prints detail or print details, and I want to take in something that satisfies the employee interface. I could pass it in like this, and what I could do is fmt println e.getName, like so, and that's going to import the format package at the top. Cool, so let's define an engineer. So engineer, let's do engineer name Elliot, and let's do print details and passing in engineer. Cool. So the issue here is, as we're using a pointer receiver on getName, we'll need to make this a pointer to the engineer struct, like so. Cool, so let's try and run this. Go run main.go. And as you can see, we've called print details, which takes in an employee or something that implements the employee interface. And then we call e.getName, which we expect to be implemented. Now, if we were to comment this out, for example, you could see instantly that my compiler, or my editor, sorry, is showing that this isn't valid as the engineer struct does not have the method getName. Now, this is effectively what I mean by the contract. By passing in an interface to the function here, we are effectively saying we need any object passed into this to implement this employee interface up the top. So let's add this back, and let's do another example. So let's do type manager struct. Let's give it a name, and let's implement this as well. So let's do m pointer to manager, and let's implement this as well. So let's return string, return manager name, and e or m.name, like so. Next, let's create a new manager. So manager and manager. Let's do name and Donna. And then let's call the print details function again. Let's pass in manager. And as you can see, the IDE isn't throwing any errors, as the manager struct does indeed implement this employee interface. It adheres to the contract that we've set out for this print details function to work. So let's try and run this. Go run main.go. And as you can see, everything has worked as expected. We've managed to call the two separate implementations of getName, hanging off the manager struct and the engineer struct. Cool. So when it comes to defining interfaces in production, you'll tend to find yourself defining these interfaces at the package or in the package which has a particular dependency. So for example, if I was defining a REST API that had to talk to a database, I would have a service in between that would define an interface that retrieved all of the items from a database, and then I could pass in any implementation that satisfied that interface. Now, this approach helps us to effectively unit test our applications better. By defining the interfaces at the package level which requires them, we can mock these out and use packages such as Vectra Mockery or GoMock. And then within our test, we could say, whenever this interface is called within our package, we expect it to return this, and then we can test the logic around the calls to these dependencies. Now, if you want to see an example of this in action, then I recommend checking out either the Go REST API course or the Go gRPC course, which follows this approach in terms of implementing or defining the interface at the package level and then mocking these dependencies within unit tests. Cool, so that's all we're going to cover within this video. Now, just to recap, in this video, we've looked at how we can define interfaces within Go. We've then looked at how we could define multiple different types of structs. So we've implemented the engineer struct and the manager struct, which effectively adhere to this contract or this interface that we have defined at the top here. We've then seen an example of how we can use this in practice by defining the print details function, which takes in anything that satisfies this employee interface, and then we call the object to be passed in and the .getName method off of that. One of the main reasons that you may have been attracted to learning Go in the first place is the performance characteristics of the language. Now, not only is it a strongly typed and compiled language, it also features great support for concurrency and building concurrent applications. Now, up until this point, we've mainly focused on building synchronous single-threaded applications. However, in this section, we're going to start to explore how we can turn these single-threaded synchronous applications into multi-threaded concurrent applications using Go routines. In this video, we're going to start this journey by looking at something called Go routines within the Go programming language. So to start off with, a Go routine is effectively a lightweight thread that we can execute some asynchronous code within in Go. Now, when it comes to instantiating Go routines or creating Go routines, we have a couple of options. Now, the first option is to use a function like so. So we could do go func, open up the function, and then we could define the body of this function. So I'm going to just do an fmt print line, hello world, save that, and it should import the format package. And next, I'm going to try and run this within the terminal. So go run main.go. And as you can see, nothing has been printed out. Now, the reason for this is our main thread has actually terminated before the child Go routine thread has been able to execute. Now, one quick way we could fix this is by adding a time.sleep. This is a very hacky way of doing this, but let's do time.second. Save that. It should import the time package. And then if I run this again, we should see that hello world is printed out. And that's because now the Go routine thread that we've spun off the main thread has had the chance to execute. Now, it should be noted, I'm just using the time.sleep method here in order to block the main thread's execution so that our Go routine can function and we can cover the Go routine topic. In the next couple of videos, we're going to be looking at better techniques that will allow us to effectively block the execution of the main thread until all of the Go routines that we spin up are complete. Okay, so we've covered how we can start a Go routine using what is called an anonymous function. Now, the more standard practice is to define a function and then use the Go keyword in front of that function call in order to start another Go routine. So let's do that now. So let's create a func hello world. And let's have it take in a name, string, and let's do fmt println hello world, or let's do hello and name, and let's change it to a printf, like so. Cool. So we can effectively change this and have hello world, and then we can pass in the argument. So let's do Elliot. And again, we're going to need this time.sleep in order to block the main thread's execution. Let's go down into the terminal, go run main.go, and as you can see, we are now calling the hello world function as a Go routine. So one final thing I want to point out in this video, when we call or create a Go routine, it does not block the execution of the main thread. So let's test this out now. Let's add a delay of 1 second, so time.second to the hello world function here. And let's do an fmt println I should be printed first. And let's increase the delay to 2 seconds. So what this effectively will do is, in the main function, it's going to trigger or create a Go routine for using the hello world function. That is then going to go off and execute on its own, but the execution of the main thread is going to continue. So we should see that the format.println statement here will execute first, and this will be printed out first. And then finally we'll see hello and Elliot getting printed out, and then the execution of the application will terminate. Cool, so let's verify that now. Go run main.go. And as you can see, what we expected happened. I should be printed first was indeed printed first, and then the Go routine, which we've triggered at the start of our main function, has then executed the hello world statement or the hello name statement. And then finally, our application has terminated after 2 seconds has passed. Cool. So in this video, we've had a fairly high level overview of the topic of Go routines and how we can instantiate Go routines using this Go keyword in front of function calls.